What we really wanted to achieve here is like, well, why make this really fast car that an electric car is the best car?
The electric vehicle industry is on the verge of what could be its most significant breakthrough yet. But this time, the revolution isn't coming from a brand new vehicle. It's coming from a battery that has the potential to redefine the future of transportation forever. For more than 10 years, lithium has ruled the industry. It powered the rise of electric vehicles, created trillion-dollar markets, and helped turn companies like Tesla into global powerhouses. Most experts expected lithium to stay on top for decades to come. Yet behind the closed doors of research laboratories, something extraordinary has been quietly taking shape. Based on emerging studies, Tesla and researchers across the globe have been exploring a technology so revolutionary that today's lithium batteries could one day look like relics of the past. This isn't just another small upgrade or an annual improvement. It's an entirely different way of storing energy, built around aluminum, one of the most abundant and cost-effective metals on the planet. Imagine a battery that charges dramatically faster, lasts much longer, costs far less to manufacture, and reduces reliance on rare minerals mined in only a handful of countries. If this technology reaches large-scale commercial production, it could transform not just electric vehicles, but also airplanes, smartphones, electrical grids, and entire economies. Businesses that fail to adapt could vanish. Nations that currently dominate the lithium supply chain could lose their competitive edge almost overnight, and the race to lead the next era of energy is already underway. Tesla built its reputation by disrupting industries that many believed could never change. Now, the company is chasing another breakthrough that could reshape the battery industry once again. If it succeeds, this advancement could become one of the decade's most important technological milestones. So before we uncover what Tesla's aluminum battery research could really mean, make sure to like this video, subscribe to the channel, and watch until the end, because the science, the competition, and the global consequences behind this breakthrough are even more incredible than most people realize. It's not simply an improvement. It completely transforms the equation. But Tesla didn't stop there. The company pushed battery technology into territory that makes traditional lithium cells appear outdated. This next-generation battery performs across a much wider temperature range, removing the need for the heavy cooling systems that today's electric vehicles depend upon. It also prevents dendrite formation, the tiny metallic spikes that gradually damage lithium batteries from inside. Even more impressive, it removes thermal runaway, eliminating the risks of battery fires, explosions, and the expensive consequences that have worried EV owners for years. The fears that once surrounded electric cars simply fade away. In their place arrives a battery that isn't only safer, it's also smarter, more durable, and designed for the future. What truly separates Tesla isn't only the chemistry, it's the strategy driving everything behind it. Aluminum is already one of the world's most widely established industrial materials. The mining operations, refining facilities, shipping networks, and recycling systems already operate on an enormous global scale. Tesla doesn't have to build an entirely new supply chain or rely on limited materials taken from environmentally difficult regions. The foundation for this revolution has been waiting all this time. While other companies spent years making small improvements to lithium technology, cutting only a few minutes from charging times or adding just a little more driving range, Tesla selected a completely different direction. Instead of competing in the same race, they created an entirely new one. By the time competitors understood what was happening, Tesla had already raced far ahead. The aluminum-ion battery isn't just an experimental idea or a forgotten patent collecting dust in storage. It's a working technology built to scale for large-scale production. Reports circulating within Tesla's network even suggest that prototype versions are already being tested in California, hidden beneath the frames of ordinary-looking vehicles that disguise a revolutionary innovation. So, what makes this battery so extraordinary? It completely breaks expectations. Traditional lithium-ion batteries usually reach around 250 W per kilogram. Tesla's aluminum-ion technology is claimed to surpass 5,000 W per kg. That isn't just another upgrade. It represents an entirely new level of energy storage. Imagine driving from San Francisco to New York without stopping to recharge. Picture restoring your battery to 100% in only 10 minutes without overheating. Without needing costly cooling equipment, without placing massive stress on charging stations, and without worrying that extreme summer temperatures could turn fast charging into a dangerous safety risk. But perhaps the most incredible claim is this: the battery is designed to greatly reduce degradation. If microscopic damage appears, the material is said to repair itself automatically. Instead of lasting only a few thousand charge cycles, it could potentially achieve 50,000 or even 70,000. Its usable lifespan could extend close to 70 years, longer than many people keep their homes. In fact, the battery could easily outlast both the vehicle it powers and the person driving it. Take a moment to think about that. This isn't simply about building a better battery. It's about removing battery anxiety completely. No more constant replacements, no more planned obsolescence, no more costly battery packs losing most of their capacity after only a few years of everyday use. And the surprises don't end there. This battery is said to include an advanced deep sleep mode that allows it to keep nearly all of its charge for up to 10 years. Imagine parking your car inside a garage, leaving it untouched for an entire decade, and returning to find it ready to drive as though it had been charged only yesterday. But these numbers don't just impact drivers. They have the potential to transform entire industries around the world. Massive supply chains worth billions of dollars exist solely to mine, refine, transport, and process lithium. What happens if those systems suddenly become unnecessary? What happens when future electric vehicles no longer need lithium, cobalt, complicated cooling hardware, or advanced software constantly controlling battery temperatures? For companies built around lithium, the consequences could be devastating. For Tesla, it could become an unmatched competitive advantage. While much of the industry continued investing billions into expanding lithium production, Tesla selected a completely different path. Instead of improving yesterday's technology, it pursued something entirely new. Now, many established manufacturers may find themselves struggling to catch up long after the opportunity has disappeared. This wouldn't be the slow decline of an aging technology. It would be a dramatic transformation, and the ripple effects would only be getting started. Tesla's aluminum-ion battery isn't just remarkable because of its performance numbers. It introduces capabilities that seem almost futuristic. Yet supporters believe this technology is no longer science fiction. It's becoming reality. One of the most remarkable features is its reported ability to heal itself. The microscopic cracks that normally weaken lithium batteries over time are said to repair automatically inside Tesla's aluminum-ion cells. Instead of gradually wearing out with repeated charging, the battery could continuously rebuild its own structure, making it far more resistant to long-term damage. It almost feels as though the battery can maintain itself. Another standout feature is its advanced deep sleep capability. Conventional lithium batteries slowly lose energy even while remaining unused, gradually draining over months or years. Tesla's design is intended to almost eliminate that loss, preserving stored energy for as long as an entire decade. Leave the vehicle parked for years, and it could still be ready to drive when you return. The possibilities reach far beyond transportation. During blackouts, severe storms, or emergencies, the vehicle could become a massive portable power station. Instead of sitting unused in the driveway, it could deliver electricity to homes, work sites, emergency shelters, or even entire neighborhoods. With energy capacities reportedly exceeding 2,000 kilowatt-hours, these battery systems could transform electric vehicles into mobile energy hubs capable of supporting critical infrastructure wherever electricity is needed. Meanwhile, much of the automotive industry remains focused on lithium. Traditional manufacturers continue investing billions into factories and production lines centered around older battery technologies. New alternatives like solid-state batteries, sodium-ion designs, and lithium iron phosphate cells continue to appear. But Tesla's aluminum-ion concept aims to outperform them all with higher efficiency, lower production costs, and greater safety. While competitors concentrate on improving existing formulas, Tesla seems determined to redefine the entire foundation of battery storage. If this technology reaches large-scale production, many rivals could find themselves struggling to defend shrinking market share. As Tesla pushes even further ahead, the financial impact alone could reshape the electric vehicle industry. Today, a typical 50 kW lithium battery pack can cost more than $7,000. Tesla's aluminum-ion equivalent is expected to cost less than $4,000, reducing the price of the most expensive component in an EV by nearly half. This breakthrough alone could lower the total cost of an electric vehicle by roughly 20%. That creates the opportunity for Tesla's next-generation EV to enter the market at a price below $16,000. Think about that for a moment. An affordable EV delivering exceptional range, impressive performance, and a battery designed with safety as its foundation. The savings don't stop with manufacturing. Aluminum-ion technology is expected to achieve recycling rates close to 95%, creating a much more efficient production cycle while greatly reducing environmental impact. Instead of depending on costly government incentives to encourage adoption, this technology has the potential to attract customers through three simple advantages: lower cost, greater safety, and stronger performance. And the impact reaches far beyond the automotive industry. This could mark the beginning of a completely new era in energy. Homes located far from the power grid could gain reliable, long-lasting electricity through mobile storage systems. Remote communities that have depended on diesel generators for decades could move directly toward cleaner, self-sufficient energy solutions. Military facilities, emergency response teams, and industrial operations could benefit from battery systems designed for decades of dependable service, dramatically simplifying long-term logistics. Imagine owning an electric vehicle that does much more than replace a gasoline car. During storms or widespread power outages, it could become the primary energy source for your home, reducing dependence on fossil fuels while supporting a more decentralized energy network. Tesla's vision goes beyond transportation. It aims to transform how energy is produced, stored, and shared. What makes this transformation remarkable is how quietly it has unfolded. There were no dramatic announcements revealing the change. Instead, progress has emerged through testing programs, manufacturing expansion, and carefully planned rollouts. While governments continue debating climate strategies and infrastructure investments, Tesla appears focused on building technologies that could fundamentally reshape those conversations. The future of energy, one that is safer, more affordable, and widely accessible, is no longer a distant idea. According to this vision, it's already beginning to take shape, powered by aluminum-based battery technology. The transition itself hasn't been dramatic, but its effects are becoming increasingly difficult to ignore. Lithium, once considered the unquestioned foundation of the EV industry, may no longer hold the same dominant position. Demand growth has slowed, suggesting the market could be entering a very different phase. Meanwhile, aluminum-ion technology is steadily attracting growing attention. Supporters believe its adoption could accelerate dramatically over the coming decade because it promises four major advantages: lower production costs, faster charging, improved safety, and abundant raw materials. Large-scale energy storage projects, from city electrical grids to commercial backup systems, are beginning to explore alternatives beyond lithium. What started as cautious experimentation is gradually becoming a practical business decision. Companies are no longer preparing for some distant future. They are responding to technologies that are emerging today. In that environment, lithium risks becoming what older communication technologies became after broadband arrived. Still functional, but no longer the first choice. Financial markets also appear to be paying close attention. Some investment firms have started directing capital toward companies developing aluminum-ion batteries instead of focusing exclusively on lithium. Rather than waiting for major announcements, many investors are positioning themselves ahead of what they believe could become the industry's next major transformation. That growing interest is placing increasing pressure on established lithium producers. Companies that once benefited from overwhelming optimism surrounding lithium now face stronger competition from alternative battery chemistries. Investors may not be abandoning lithium entirely, but many are diversifying their portfolios because technological leadership, rather than brand loyalty, often determines the long-term winners. Looking at the bigger picture, the consequences could reach across entire industries. Global lithium mining, refining, and processing represent investments worth hundreds of billions of dollars. Nations, multinational corporations, and major investors have spent years building infrastructure around lithium extraction. If aluminum-ion technology eventually achieves widespread adoption, much of that infrastructure could face serious challenges. Expensive refining facilities, transportation networks, and long-term supply agreements may become less valuable if manufacturers move toward more abundant materials. Environmental concerns and geopolitical risks surrounding lithium and cobalt mining would only speed up that transition. Cobalt, especially, could become increasingly unnecessary if next-generation batteries completely remove the need for it. Procurement systems, long-term contracts, and complicated sourcing strategies built around cobalt would suddenly become far less important. Government policies could shift as well. Subsidy programs designed around today's battery technologies may gradually evolve toward newer chemistries that offer lower costs, easier recycling, and greater safety. Insurance companies could also encourage adoption if batteries with lower fire risks eventually receive more favorable coverage. That raises an important question. Where does Tesla go from here? Historically, Tesla has focused less on following industry trends and more on creating them. Reports suggest the company's energy storage business may become the first platform for aluminum-ion deployment. The Megapack, Tesla's large-scale battery system for electrical grids, is widely considered the most likely starting point. Some industry speculation even suggests aluminum-powered versions could arrive sooner than many people expect. If that happens, passenger vehicles may not be far behind. One possibility frequently discussed is Tesla's long-rumored affordable Model 2. If paired with aluminum-ion technology, it could combine a lower purchase price with improved safety, ultra-fast charging, and longer driving range. Such a combination would represent a major shift for the electric vehicle market, potentially redefining expectations for affordability, performance, and reliability. The opportunities stretch far beyond passenger cars. The same battery chemistry could eventually power drones, marine vessels, aircraft, residential energy systems, commercial storage facilities, and even national electrical grids. A single technological platform could support an enormous variety of industries. Once that happens, the benchmark for battery technology wouldn't simply improve. It could be completely redefined. Automakers would rush to adapt. Utility companies would rethink energy planning. New startups would enter the market, and governments would likely revise long-term energy strategies. Because if aluminum-ion batteries ultimately deliver on these promises, the change wouldn't represent just another product launch. It would signal the beginning of an entirely new era in energy storage. What we're witnessing isn't a small glimpse of tomorrow. It's a complete rewrite of yesterday. The lithium era isn't simply fading into history. According to this narrative, it's being challenged by a technology that promises to outperform it across nearly every category. Tesla didn't just introduce another battery concept. It positioned itself as a company determined to move beyond older technology, sending a clear message to the rest of the industry. Adapt quickly or risk being left behind. The advantages are difficult to ignore. Lower production costs, greater safety, reduced dependence on controversial mining practices, and fewer complicated supply chains. This isn't presented as a routine engineering improvement, it's described as a fundamental shift in how batteries could be designed. While many traditional automakers continued refining hybrid systems and improving existing lithium technology, Tesla selected a different path. Instead of making gradual improvements, it focused on creating an entirely new foundation for electric mobility. Now, much of the industry finds itself racing to respond. Aluminum-ion technology didn't arrive with loud fanfare or celebration. It arrived with the potential to challenge decades of assumptions. And if this transition continues building momentum, Tesla may not have simply opened the door to the next generation of batteries. It may have been the very first company to walk through it.